Here's our next practice in Hess's Law. Let's see if we've reached a common answer. As I read the first elementary reaction, copper is combining with chlorine to produce copper 2 chloride, an exothermic reaction. Second equation, 2 coppers with a chlorine produce 2 units of copper 1 chloride. Different names based on the charge of the copper. Again, an exothermic process. How can we combine these two reactions to form the target equation? Building from these two, let's create the target. Well, again, I like to start, for no other reason than it's written first, with the first reactant in the target equation. Here's what I like about it. Copper as a solid is written on both sides of the equal here, so it's not in a unique position. The first reactant I'm really not finding too helpful to get any ideas what to do with the elementary reaction. Let's see if we can find something else unique. Here is copper 2 chloride as a solid, and that particular reactant is in a unique position. Only one of them appears, and it's in the first equation. I like how many I have, but it's on the incorrect side of the arrow. So I think what I'm going to do is rewrite this first equation and flip its direction. So CuCl2 as a solid will go to Cu as a solid and Cl2 as a gas. Since I flipped the direction, the delta H goes from negative to positive 206 kilojoules of heat. Let's see what else we have. The product is 2 copper chloride solids. Well, that's exactly written in the correct position in that second equation above, and it's the correct number. Could it have been as easy to flip the first and leave the second? Let's take a look. If our strategy indeed is correct, it should simplify to create the target. If I flip the first, leave the second as is, let's see if indeed it simplifies. I notice chlorines will cancel out. It's a product in the first equation, a reactant on the other. They will cancel. I have 1 unit of copper solid, 2 units on the left in the second equation. That's going to give me a net of 1 copper. I think it really was that easy. 1 copper is remaining, plus copper 2 chloride on the left side of the arrow, giving us 2 copper chlorides, the only products left in our equation. All we have left to do is to add to find the new heat of reaction. We'll take positive 206 and add a negative 36. I'll try that again. Positive 206 plus a negative 36, and we get 170 kilojoules of heat energy. Perfect. I hope that matched yours.